Hello, my name is Alex Hayes and I'm the Key Stage 5 Coordinator for Maths here at Cardinal Newman. A-Level Maths is a stimulating and challenging course which increases your knowledge and understanding of mathematical techniques and their applications. A-Level Mathematics is the most popular A-Level chosen nationally for good reason. You will develop key employability skills such as problem solving, logical reasoning, communication and resilience. In addition, it supports the study of a variety of other A-levels as well as providing excellent preparation for a wide range of university courses. The A-level in mathematics is split into three sections. Pure mathematics. This is the methods and techniques which underpin the study of all other areas of mathematics such as proof, algebra, trigonometry, calculus and vectors. The next area is mechanics. This is a study of the physical world, modelling the motion of objects and the forces acting on them. Students planning careers in physics or engineering would find mechanics particularly useful. Finally, there's statistics. This is working with data from a sample to make inferences about a population, probability calculations, modelling real-life data using statistical distributions and hypothesis testing. The majority of private sector organisations believe the use of data analytics will be the most important factor in increasing growth in UK businesses. The A-Level Mathematics course is a 2-year course which is assessed at the end of Year 13 with 3 written papers. There is no coursework element. As well as studying for your A-Level qualification, there are many opportunities to enrich your mathematical education here at Cardinal Newman. Opportunities include taking part in regional and national mathematical competitions, going on trips to hear inspirational mathematical speakers, and the opportunity to become mentors and role models to younger students aspiring to become A-level mathematicians themselves. Further Mathematics is an additional AS or A-level qualification taken in addition to AS or A-level mathematics. It is designed to stretch and challenge able mathematicians and prepare them for university courses in mathematics and related quantitative and scientific subjects. Although Further Maths runs in parallel with normal A-level mathematics, there are many common skills and techniques, meaning your progress in normal A-level mathematics will be greatly enhanced by choosing to study Further Maths. A-level Further Maths is made up of 50% pure mathematics and then 50% applied mathematics, in which you study further topics in statistics, as well as a whole new branch of mathematics known as discrete mathematics. The Further Mathematics A-Level is a 2-year course which is assessed all at the end of Year 13 with 3 written papers. There is no coursework element. 2 examples of important Further Maths pure topics are complex numbers and matrices. Matrices are used extensively in computer graphics, and complex numbers are a vital part of electronic circuit design. One area of discrete mathematics is graph theory, which includes solving problems such as what would be the most efficient route for delivering post around a network of streets. This topic uses algorithms vital in computer science. In summary, A-Level Further Mathematics is a challenging but rewarding choice and the perfect stepping stone on a course of rich variety of careers, all with strong mathematical elements.
Something I like about Further Maths is that I find the topics to be very engaging due to how different they are to GCSE. So for example, the first topic I learned in Year 12 was about imaginary numbers, something you don't get to study in ordinary maths. So I'd definitely recommend it for those of you who have a genuine interest for maths, because I feel like there's a very good balance between how challenging a topic is and how interesting it is. Whereas ordinary maths is split into pure statistics and mechanics, Further Maths is made up of pure statistics and decision. The pure and statistics follow on quite nicely from GCSE and A-level maths, but the decision will be something you haven't done before. However, I think it's the most accessible topic following GCSE, and there's very little algebra involved, so it does break up the course quite nicely. Decision maths involves using algorithms and step-by-step methods in order to find the optimal solution to real-life situations. Personally, I think this allows you to see the real-world benefits of maths quite clearly and how it can be used in different jobs. Further Maths can also be quite useful if you're considering a maths degree, because some universities will offer you a reduced entry grade just for studying it. So for example, an offer of A*A* could be lowered to A*AA just because you take Further Maths. So it's definitely worth looking into if you're unsure of what you want to do at universities. And it's also worth keeping in mind that some of the top universities will require you to take Further Maths. So again, it's definitely worth looking into. Also, I found that taking Further Maths alongside ordinary maths has been incredibly helpful, because a lot of the topics that you learn in Further Maths follow on directly from something you learn in ordinary maths, which gives you a greater understanding of the topic as a whole. I also find it easier to balance in terms of workload because the topics are so similar that skills you learn in one can be transferred directly across both subjects. There's no coursework, so you're assessed with 3 2-hour-long exams, all taken at the end of year 13. The first 2 papers are made up of just pure maths, but the third paper is split 50-50 between decision and statistics.
A-level maths is a subject where you learn and apply different skills that can be used in real life. You have 3 2-hour papers and no coursework. 2/3 of the exam is pure and 1/3 is applied. Applied is mechanics and statistics. In A-level maths you study 3 divisions. They are pure, mechanics and statistics. Each division has subdivisions within them. For example, pure has components such as algebra, differentiation, integration and much more. Statistics is the maths dealing with analysis, interpretation and numeric data. Mechanics is the math in Newton's law, vectors, acceleration, energy and power and much more. There are many things to enjoy about A-level maths, but one of the main things I enjoy is learning the concept behind everything and how everything was developed and found. Another thing I love about maths is algebra. Algebra is a challenging topic, but once you know and understand it, it becomes so much more easier and much enjoyable. Algebra is a massive part of GCSE and A-level maths. A-level maths might seem easy at the start, but it is a huge jump from GCSEs. Everything you learn in GCSE builds up to A-level maths, but there is much more depth to everything. GCSE is like the core part to A-level maths. Maths is a great option to take for many reasons, but one of the main reasons are for university applications and courses. Maths is a very strong and competitive field in university and many other courses. Maths opens so many doors for careers, whether that's in university, apprenticeships and much more. It supports subjects such as chemistry, physics, engineering, maths, business, IT and much more. Any science with maths is also a great combination for competitive fields such as medicine, biology, chemistry and many more. Maths also makes your application much stronger and shows a lot of skills they look for, such as problem solving, decision making, analysing data and breaking down bigger problems into sub-problems. Overall, maths is a great subject to take and will provide a bright career in pretty much any field.
So if we're thinking about it a bit more generally, rather than it being 5x, it was just kx, where k is a constant, we could do u equals kx, and then we could follow that through with the chain rule, and what would we end up with, Jessica?
K cos kx.
K cos kx, yeah. Don't forget you've got your factor of k. So it'd be minus k sine kx. Because you kind of know that you're going to do u equals what you're taking the sine of, differentiate that and multiply. So these are useful little results to know.